Have you ever looked up at the night sky and wondered what's really out there? From the tiniest particles of dust to galaxies billions of light years away, the universe is full of mysteries waiting to be explored. In this journey, we'll uncover 100 fascinating facts about space and its connection to Earth, revealing how our planet fits into the cosmic story. Fact 1. The size of the universe. Bigger than we can imagine. Have you ever tried to imagine something so big it doesn't even make sense? That's the universe. When we look up at the night sky, we see stars scattered like glitter, and it feels infinite already. But in reality, what we see is just the tiniest fraction of everything out there. Galaxies, stars, planets, and unknown objects stretch far beyond what our minds can grasp. Some scientists estimate the universe is at least 93 billion light years across. That's 93 billion years of light travelling, just to give you a scale. And the mind-boggling part, it might be even bigger. If you think about the Earth as a tiny dot, the solar system is like a grain of sand. The Milky Way, our galaxy, is a city of hundreds of billions of stars. And then there are billions of galaxies, each with its own billions of stars. Even the speed of light, which is the fastest thing we know, would take tens of thousands of years just to cross one galaxy. That means when we look at distant galaxies, we're not seeing them as they are today, we're seeing their past. It's like looking through a time machine that stretches across unimaginable distances. What's even more fascinating is that the universe doesn't have obvious walls or edges, it just keeps going. Scientists debate whether it's infinite, or if it has some hidden boundaries we simply can't detect. Either way, thinking about its size is almost overwhelming. Some experts say trying to picture it in our minds is like imagining an endless ocean, only this ocean stretches in all directions, filled with lights, matter, and mysteries we've barely begun to understand. And here's a twist. The universe is still growing. Not slowly, but expanding faster than you might expect. That means the distances between galaxies are increasing every moment. So even if we could somehow travel at unimaginable speeds, most parts of the universe would stay forever out of reach. It's humbling, exciting, and a little scary all at once. So next time you glance at the night sky, remember, the tiny specks you see are just a glimpse of something vast beyond your imagination, and that vastness holds secrets, stories, and surprises that we're only starting to uncover. The universe isn't just big, it's bigger than we can imagine. Fact 2. The Big Bang. How it all began. Imagine everything around you compressed into something smaller than the tiniest dot you can see. That's where the story of the universe begins, the moment we call the Big Bang. Around 13.8 billion years ago, the universe as we know it didn't exist. No stars, no planets, not even space as we understand it. And then, suddenly, a massive expansion happened. Not like an explosion with fire and sound, but a rapid stretching of space itself. At first, the universe was unimaginably hot and dense. A soup of particles moving faster than anything we can truly picture. In the blink of an eye, or maybe less than that, space expanded, temperatures dropped, and the building blocks of everything started forming. Hydrogen, helium, and traces of other elements were born, drifting in the expanding universe. These tiny particles would eventually gather, forming stars, galaxies, and planets. The Big Bang wasn't an explosion into empty space. Space itself was growing. Imagine drawing dots on a balloon, and then inflating it. The dots move apart not because they're travelling across the balloon, but because the balloon itself is stretching. That's how galaxies moved away from each other in the early universe, and the light from that ancient moment. We can still detect it today, faint but real, as cosmic background radiation, a ghostly whisper from the universe's first moments. It's amazing to think that everything we know, Earth, the Sun, even us, came from that tiny, energetic beginning. And even now, the universe keeps expanding, carrying galaxies farther and farther apart. What started as a simple burst of energy became the vast cosmos we explore with telescopes, satellites, and our imagination. The Big Bang is more than a moment in history. It's the story of how everything started, the ultimate origin of matter, energy, and space. And it reminds us that even the most complex things have a simple, astonishing beginning. Fact 3. Cosmic inflation, the universe's early growth spurt. If the Big Bang was the universe's birth, cosmic inflation was like its first sprint. Right after the Big Bang, the universe didn't just expand, it exploded outward at speeds faster than light. Wait, faster than light? That might sound impossible, but it's important to know that it wasn't matter travelling, it was space itself stretching at an incredible rate. This early growth spurt happened in a fraction of a second, yet it set the stage for everything we see today. Imagine a tiny seed suddenly growing into a massive tree in less than a heartbeat. Inflation smoothed out irregularities, spread matter evenly, and created the perfect conditions for stars, planets, and galaxies to form later. Without it, the universe might be a chaotic mess instead of the structured cosmos we explore. Cosmic inflation also explains a strange mystery: why the universe looks so uniform no matter which direction we look. Galaxies billions of light years apart share similar patterns, temperatures, and structures, as if they were in contact in the very early moments of the universe. That's inflation at work. It stretched everything evenly, creating a cosmos that feels balanced and familiar, even on an enormous scale. Scientists have tested this theory through observations of the cosmic microwave background, the faint light left from the universe's earliest moments. Tiny fluctuations in this light match the predictions of inflation almost perfectly. And while inflation happened incredibly fast, its effects are still visible today, shaping the very fabric of space and the large-scale structure of galaxies. Cosmic inflation might be invisible to our eyes, but it's a cornerstone of the universe's story. It's the secret behind why stars cluster in galaxies, why the universe is smooth in some ways, and why our tiny planet exists in a predictable, structured cosmos. Thinking about it makes the universe feel alive, stretching, and full of wonder, even from the very beginning. Fact 4. The observable universe. What we can actually see. When you look up at the night sky, it feels infinite, right? But there's a limit to what we can see, and that limit is called the observable universe. Basically, it's everything from which light has had time to reach us since the Big Bang. And yes, that's still enormous, about 93 billion light-years across. That's not just a number, it's a mind-bending reality. What's fascinating is that when we look at distant stars and galaxies, we're looking back in time. Light from a galaxy a billion light-years away left that galaxy a billion years ago. So in a way, telescopes are time machines, letting us see the universe as it was in its youth. This means some of the galaxies we observe might not even exist in the same form today, but the observable universe is only part of the story. Beyond it, there's space we cannot see. Light from there hasn't had enough time to reach us. That means most of the universe is hidden, possibly infinite, or at least far larger than what we can detect. It's humbling and thrilling to know that no matter how advanced our technology becomes, a huge part of reality remains just out of reach. Observing the universe has taught us incredible lessons. It shows us patterns, structures, and cosmic connections that explain why stars cluster, galaxies form, and planets like Earth exist. And each new discovery, whether from ground-based telescopes or space observatories, expands our perspective, reminding us how small we are and yet how much we can learn. Looking at the observable universe isn't just about seeing distant objects, it's about seeing our place in a vast unfolding story. Every point of light is a chapter in that cosmic narrative, and we're lucky to read it, even if we can't read it all. Fact 5. Dark matter, the invisible majority. Here's a curious fact. Most of the universe isn't made of the stuff we can see. Stars, planets, gas, they're only a tiny fraction. The rest is called dark matter, an invisible, mysterious substance that holds galaxies together. We can't see it, touch it, or detect it directly, but we know it's there because of the way it affects things we can see. Think of a spinning galaxy. If only visible matter existed, stars at the edges would fly off, but they don't. Something unseen is holding everything in place. Dark matter. It's like an invisible skeleton that shapes the cosmos, guiding galaxies and influencing the universe's large-scale structure. Scientists have tried all kinds of experiments to find it: detectors underground, particle colliders, space telescopes. But dark matter remains elusive. That's part of what makes it so fascinating. It's a mystery we know exists, yet we have barely touched its surface. Dark matter also connects to other cosmic mysteries, like how galaxies form, how the universe expands, and even what will happen in the far future. Without it, the universe would look very different, possibly chaotic and less structured. In a way, dark matter is the quiet, unseen force that keeps the universe orderly, even if we don't notice it day to day. So next time you look at the night sky, remember, most of what's out there isn't visible at all. The stars and planets are only the tip of the iceberg. The real bulk of the universe is invisible, mysterious, and still waiting for us to understand it. Dark matter is a reminder that even in a universe we think we know, there are secrets hiding in plain sight. Fact 6. Dark energy. The force. Expanding everything. Imagine you throw a ball into the air and instead of slowing down, it keeps accelerating. Weird, right? That's a little like what dark energy does, but on a cosmic scale. Dark energy is this mysterious force that's making the universe expand faster and faster. We don't know exactly what it is, but it's everywhere, filling space, quietly pushing galaxies away from each other. Before scientists discovered it, we thought gravity would eventually slow the universe down. But observations in the late 20th century shocked everyone. Distant galaxies were moving away faster than expected. Something invisible was at work, and we call it dark energy. It's mind-boggling to think that around 70% of the universe is made of something we can't see or touch. Dark energy shapes the ultimate fate of the universe. If it keeps dominating, galaxies could drift so far apart that the night sky becomes mostly dark, with stars scattered and unreachable. On the other hand, we might not fully understand it yet. It could even change over time. Even though dark energy is invisible, its effects are enormous. It determines how galaxies cluster, how cosmic structures form, and how the universe evolves. It's like the quiet director of a play, unseen but controlling the story from behind the curtains. Thinking about it is humbling. So much of the universe's fate depends on something we can't directly detect, yet its influence is everywhere. Fact 7. Galaxies. Islands of stars. When you look at the night sky, the stars might seem scattered randomly, but most of them are part of galaxies. Enormous islands of stars, gas and dust bound together by gravity. Each galaxy can contain billions, even trillions of stars, along with planets, nebula, and sometimes black holes. Galaxies come in different shapes and sizes. Spirals, like our Milky Way, have swirling arms when new stars are born. Elliptical galaxies are more rounded and older, often lacking new star formation. Then there are irregular galaxies, oddly shaped and chaotic, likely the result of collisions or gravitational pulls from neighbours. Galaxies aren't just beautiful, they're essential. They organise the universe, providing environments where stars form, live, and die, and even influence the formation of planets like Earth. And they're social in a way. They group together into clusters, interact, and sometimes collide, creating spectacular cosmic fireworks. When you realise that every visible point in a telescope could be a whole galaxy, it completely changes perspective. The night sky isn't just dots, it's billions of cosmic cities, each with its own story, history, and secrets waiting to be explored. Fact 8. The Milky Way, our galactic home. Let's bring it closer to home, our galaxy, the Milky Way. Picture a giant spinning pinwheel of stars, gas, and dust stretching across the sky. That's us. The Milky Way is a spiral galaxy, about 100,000 light-years wide, containing hundreds of billions of stars. Our Sun is just one of those stars, orbiting the galaxy's centre at a staggering speed of over 500,000 miles per hour. The Milky Way is more than just stars. Between them lies gas and dust clouds, the raw material for new stars, and hidden black holes that quietly influence their surroundings. Its spiral arms are like cosmic highways, where star formation is most active. And the centre, a supermassive black hole, millions of times the mass of the Sun, quietly anchoring the galaxy. When we look at the Milky Way from Earth on a clear night, we see it as a glowing band stretching across the sky. That faint light is billions of distant stars, all part of the same cosmic home. And even though we live on a tiny planet orbiting a fairly average star, the Milky Way connects us to the broader universe, reminding us how small and yet how deeply part of the cosmos we are. Fact 9. Andromeda, our future collision course. Here's a cosmic twist. The Milky Way isn't the only galaxy in our neighbourhood. About 2.5 million light-years away lies Andromeda, another massive spiral galaxy. It's heading straight toward us, not at walking pace, but at an incredible speed of around 120 miles per second. Don't worry, we have a few billion years before anything dramatic happens. When galaxies collide, it's not like bumper cars. Stars are so far apart that most will never directly crash. But gravity will pull the two galaxies together, distorting their shapes, triggering bursts of star formation, and sending clouds of gas spiralling into new areas. Eventually, the Milky Way and Andromeda are expected to merge, forming a giant elliptical galaxy, sometimes nicknamed Milkomeda by astronomers. This future collision is fascinating because it shows how dynamic galaxies are. They aren't static islands. They interact, evolve, and reshape themselves over billions of years. And it's a reminder that even on a cosmic scale, change is constant. The universe isn't frozen. It's alive, moving, and full of stories that unfold over unimaginable timescales. Fact 10. Galaxy clusters. Cosmic cities. If one galaxy is like a city, then a cluster of galaxies is like an entire metropolis. Galaxy clusters are collections of hundreds or even thousands of galaxies bound together by gravity. They can stretch millions of light-years across, forming some of the largest structures in the universe. Inside a cluster, galaxies interact, merge, and sometimes even collide, creating dramatic bursts of star formation. Invisible dark matter we mentioned earlier helps hold these clusters together like a hidden scaffolding. And between the galaxies, hot gas glows brightly in X-rays, adding another layer to the cosmic cityscape. Clusters also aren't isolated. They group into even larger structures called superclusters, forming a web-like pattern across the universe. It's almost like looking at a cosmic map of interconnected cities and highways, spanning billions of light-years. And while we see only part of this vast web, each discovery reminds us how structured and interconnected the universe really is. Galaxy clusters are more than beautiful. They're evidence of the universe's incredible scale, organization, and hidden forces at work. Standing under the night sky, thinking about these massive cosmic cities makes Earth feel small, yet part of something profoundly magnificent. Fact 11. What makes a star shine? Have you ever wondered why stars twinkle in the night sky? That light you see isn't just decorative. It's the result of something truly amazing happening deep inside each star. Stars shine because of nuclear fusion, a process where hydrogen atoms smash together under extreme pressure and heat to form helium. This reaction releases an incredible amount of energy, and that energy eventually escapes as the light we see from Earth. Think of it as a massive, self-sustaining furnace. The core of a star is unimaginably hot, millions of degrees, and the energy generated pushes outward, balancing the crushing force of gravity trying to collapse the star. This balance, known as hydrostatic equilibrium, keeps the star stable for millions or even billions of years. Without it, stars could collapse or explode in ways that would disrupt everything around them. What's fascinating is that the colour and brightness of a star depend on its temperature and size. Hotter stars glow blue or white, while cooler stars appear red. Some stars are small and dim, barely visible without a telescope. Others are massive, like supergiants, shining so brightly they can outshine entire clusters of stars. The light from a star also tells a story about its age and composition. By studying it, astronomers can determine how long a star has been burning, what elements it contains, and even clues about planets that might orbit it. So when you look up at a star tonight, remember it's not just a distant point of light, it's a fiery, dynamic ball of energy, quietly shaping the universe around it. Fact 12. Life cycle of stars. Birth to supernova. Stars aren't eternal. They have a life story, just like living beings. It all starts in stellar nurseries, clouds of gas and dust called nebulae. Gravity pulls the material together, forming a dense core that heats up until nuclear fusion begins. Congratulations! A new star is born. Smaller stars like our Sun live quietly for billions of years, fusing hydrogen into helium and radiating steady light. Massive stars, however, burn faster and live shorter, more dramatic lives. Eventually, as stars exhaust their fuel, small to medium stars swell into red giants, shed outer layers, and leave behind dense cores called white dwarfs. Massive stars have a more spectacular fate. When their cores collapse, they explode as supernovae, blasting elements into space and seeding future stars and planets. These explosions are so bright they can outshine entire galaxies for weeks. Without supernova, elements like iron, calcium, and even oxygen, key to life, would never exist. The life cycle of stars is a cosmic recycling process. Stars are born, live, die, and their remnants help create new stars and planets. In a way, every atom in your body was once inside a star. So next time you gaze at the sky, remember, the stars above aren't just lights. They're storytellers of creation, transformation, and cosmic connection. Fact 13. Neutron stars, densest objects in the universe. Imagine squeezing a star's mass, bigger than our Sun, into a sphere only a few miles across. That's a neutron star, one of the densest objects in the universe. A single teaspoon of the neutron star material would weigh billions of tons on Earth. It's a mind-boggling concept that pushes our understanding of physics to the limit. Neutron stars form from the remnants of massive stars that exploded as supernovae. When the core collapses, protons and electrons merge into neutrons, creating a tiny, ultra-dense object. Gravity is so intense that the star's surface is extreme, just a few miles thick, yet containing more mass than the Sun. Neutron stars also have incredibly strong magnetic fields and rotate at mind-blowing speeds. Some spin hundreds of times per second, emitting radiation from their poles. Observing neutron stars gives scientists insight into matter under conditions impossible to recreate on Earth. These stars remind us of the universe's extremes. They're small, yet colossal in mass, seemingly fragile, yet unimaginably strong. And they play a role in shaping galaxies, generating gravitational waves, and even producing heavy elements during collisions. Neutron stars are proof that the cosmos doesn't just exist, it stretches our imagination. Fact 14. Pulsars, cosmic lighthouses. Some neutron stars take things a step further and become pulsars. Imagine a star spinning so fast that it sweeps beams of radiation across space like a lighthouse. When those beams cross Earth, we detect them as regular pulses of light or radio waves, sometimes hundreds of times per second. Pulsars are fascinating for a few reasons. Their rotations are incredibly precise, often more consistent than atomic clocks. Scientists use them to measure distances, test physics theories, and even detect gravitational waves. Pulsars are like cosmic timekeepers, quietly ticking away while the universe unfolds around them. The pulses aren't just fascinating. They're a reminder that even after a star dies, it can continue influencing the universe in remarkable ways. Pulses demonstrate extreme physics in action, helping us understand magnetism, rotation, and matter at unimaginable densities. Looking at them is like peering into a cosmic metronome, where each beat tells a story of a star's dramatic life and enduring legacy. Fact 15. Black holes, gravity's extreme form. Black holes are the ultimate extreme of gravity. Imagine a star collapsing into a point so dense that not even light can escape. That's why we call it a black hole. Nothing inside can be seen from the outside. Despite their mysterious reputation, black holes are natural consequences of massive stars reaching the end of their life cycle. They come in different sizes. Stellar black holes form from dying massive stars, while supermassive black holes, millions or billions of times the Sun's mass, sit at the centres of galaxies, including our Milky Way. These giants shape galaxy evolution, control star orbits, and influence cosmic structures on enormous scales. Approaching a black hole is extreme. Gravity stretches and compresses objects in a process called spaghettification, pulling matter into the black hole's core. Around them, swirling disks of gas and dust heat up, glowing brilliantly before being swallowed. Observing these effects gives scientists clues about gravity, space-time, and the universe's most extreme environments. Black holes are not just destructive, they're central to understanding the universe. They remind us that even invisible forces can shape reality, holding galaxies together and fueling cosmic mysteries. Studying them pushes human curiosity to the limits and keeps us questioning what's really possible in the cosmos. Fact 16. Event horizon, the point of no return. Imagine approaching the edge of something so powerful that nothing can escape, not even light. That's the event horizon of a black hole, the ultimate boundary in space. Once anything crosses it, there's no turning back. It's not just a line in space, it's a threshold where gravity becomes absolute, and the rules of physics as we know them start to bend. Outside the event horizon, objects can orbit or escape, but step past it, and you're trapped. Not gradually, not slowly. The pull increases as you get closer, stretching and compressing matter in ways that defy imagination. Scientists often describe this as spaghettification, because objects elongate as gravity pulls them in. It's a strange, almost poetic image for something so extreme. Even though we can't see inside, we detect event horizons by observing the effects on nearby stars and gas. Swirling disks of superheated matter orbit just outside, glowing brightly before being swallowed. That light and motion give us indirect evidence of the black hole's presence. The event horizon is more than a cosmic boundary, it's a reminder of limits. It's the ultimate point of no return in the universe, showing how gravity can dominate and shape reality. And while we can study it from a distance, we'll probably never truly experience it firsthand. Fact 17. Supermassive black holes, monsters at galaxy centres. At the heart of nearly every galaxy lurks a supermassive black hole, millions or even billions of times the mass of the Sun. These cosmic giants aren't just passive objects, they dominate their surroundings, controlling the orbits of stars, influencing gas flows, and even shaping galaxy evolution. Unlike stellar black holes, which form from single massive stars, supermassive black holes' origins are still somewhat mysterious. Some may have grown from early massive stars merging and consuming material over billions of years. Others could have formed directly from dense regions in the early universe. Either way, their gravity is enormous, holding galaxies together like an invisible anchor. Sometimes these black holes become active, feeding on surrounding gas and dust. As material spirals in, it heats up, emitting intense radiation visible across billions of light years. These active galactic nuclei can outshine entire galaxies, proving that even invisible objects can have a profound cosmic influence. Supermassive black holes remind us that the universe is full of extremes. They're hidden yet essential, shaping the very structure of galaxies and offering a window into the forces that govern space on the larger scales. Fact 18. Binary star systems. 2 stars. Dancing. Not all stars are solitary like our Sun. Some live in pairs, called binary star systems, locked in a gravitational dance around a common centre. These cosmic duets vary widely. Some stars orbit closely, exchanging mass, while others are far apart, barely affecting each other except for their mutual tug of gravity. Binary systems are fascinating because they reveal how stars evolve. When one star expands, it can transfer material to its partner, altering both stars' fates. In some cases, this interaction can trigger spectacular explosions like novae or even supernovae. Observing binary stars also allows astronomers to measure star masses and sizes, helping us understand the fundamental rules of stellar physics. And when binaries spin rapidly or interact in extreme ways, they can produce phenomena like X-ray emissions or gravitational waves, providing a natural laboratory for studying the universe's most powerful forces. Binary stars are proof that even on a cosmic scale, relationships matter. These duets of matter and energy are constantly influencing each other, shaping their surroundings and creating dynamic stories across the galaxy. Fact 19. Star clusters. Families of stars. Stars often form in groups, creating star clusters that move together through space like cosmic families. These clusters vary in size and age. Some are young and open, with loosely connected stars, while others are dense and ancient, containing hundreds of thousands of stars tightly packed in spherical formations. Star clusters are fascinating because they offer a glimpse into stellar evolution. Since the stars in a cluster formed roughly at the same time from the same cloud of gas, astronomers can study them to understand how stars change over time. Young clusters sparkle with bright blue stars, while older clusters glow red, hinting at generations of stellar life cycles. Clusters are also beautiful to observe. In the night sky, they appear as glittering patches, sometimes barely visible to the naked eye but brilliant through telescopes. These stellar families remind us that stars rarely live in isolation. They are part of interconnected systems, creating order and beauty on a vast scale. Fact 20. Stellar nurseries, where stars are born. Every star has a beginning, and most start life in stellar nurseries, vast clouds of gas and dust known as nebulae. Gravity pulls material together, forming dense regions that heat up until nuclear fusion ignites. That's when a new star flickers to life, beginning a journey that can last millions or even billions of years. Stellar nurseries are chaotic and dynamic. Gas clouds swirl, collide, and fragment, producing multiple stars at once. Some regions form massive stars that burn brightly and live fast, while quieter pockets give birth to smaller, long-lived stars. Observing these nurseries is like watching a cosmic workshop, where raw materials assemble into objects that may one day host planets, solar systems, and perhaps life. These nurseries also scatter material back into space. Stellar winds and radiation shape the surrounding clouds, triggering the next generation of star formation. In a way, the universe recycles itself continuously, producing new stars, new planets, and new possibilities. Looking at a nebula, it's impossible not to feel a sense of wonder. Every twinkle, every glow, started as tiny particles of gas pulled together in a stellar nursery. It's a reminder that even the most brilliant lights in the sky had humble beginnings, emerging from quiet clouds in the vastness of space. Fact 21. The Sun, the heart of our system. Look up on a clear day and you see it. A blazing ball of light that feels impossibly close, yet it's actually about 93 million miles away. That's our Sun, the heart of the solar system, quietly powering everything around it. Without it, Earth would be a frozen, lifeless rock drifting in darkness. The Sun isn't solid. It's a massive sphere of hot plasma, mostly hydrogen and helium. Deep in its core, nuclear fusion converts hydrogen into helium, releasing energy that radiates outward as light and heat. That energy takes thousands of years to reach the surface, but once it escapes, it travels at the speed of light, bathing Earth in warmth and life. Its gravity keeps the planets in orbit, making sure Mercury, Venus, Earth, and the rest follow predictable paths. Even comets, asteroids, and distant objects feel its pull. And while it seems constant, the Sun has moods. Solar flares and sunspots are reminders that it's dynamic, not just a calm ball of fire. The Sun also shapes life on Earth in invisible ways. Seasons, climate, and weather all depend on its energy. Photosynthesis, the process plants use to create food, relies entirely on sunlight. Even our sleep cycles are tuned to its rhythm. In short, the Sun isn't just a star. It's the quiet engine of this solar system, a giant sphere of energy making life possible on our tiny blue planet. Fact 22. Mercury, the smallest planet. If you think Earth is small compared to the Sun, Mercury is practically tiny in comparison. It's the smallest planet in the solar system, barely larger than our Moon. But don't underestimate it. Mercury is a world of extremes and surprises. Closest to the Sun, temperatures soar during the day, reaching over 800 degrees Fahrenheit, and plunge at night to nearly minus 300 degrees. Its thin atmosphere can't retain heat, leaving it exposed to solar radiation. Despite these harsh conditions, Mercury has a story to tell. Its surface is covered in craters and cliffs, evidence of violent impacts and ancient geological activity. Mercury's orbit is unusual too. It completes a year in just 88 Earth days, moving faster than any other planet. This rapid orbit, combined with slow rotation, creates strange day-night cycles, giving sunrise and sunset patterns unlike anywhere else in the solar system. Even though it's small and seemingly inhospitable, Mercury teaches us a lot about planetary formation, gravity, and the effects of the Sun's immense energy. It may be the smallest planet, but it's packed with fascinating features that make it a key player in understanding our solar neighbourhood. Fact 23. Venus, Earth's twin. The distant Venus is often called Earth's twin because it's similar in size and composition, but the comparison stops there. While Earth is blue and full of life, Venus is a searing world of thick clouds, crushing pressure, and extreme heat. Its atmosphere is mostly carbon dioxide, trapping heat in a runaway greenhouse effect, making the surface hotter than Mercury, even though it's farther from the Sun. Venus rotates slowly and backward, so a day on Venus is longer than its year. Imagine watching the Sun rise in the west and set in the east. That's a day on Venus. The surface is hidden beneath dense clouds, but radar mapping has revealed vast volcanic plains, mountains, and evidence of massive lava flows. Despite its inhospitable conditions, Venus fascinates scientists. Its thick clouds reflect sunlight, making it one of the brightest objects in the sky. And studying Venus helps us understand climate dynamics, greenhouse effects, and even hints about Earth's past and future. Venus may look peaceful from afar, but up close, it's a world of extremes. Fact 24. Earth, our blue planet. Earth may feel ordinary because it's our home, but in the cosmic scale it's extraordinary. It's the only planet we know that supports life, with oceans, continents, and an atmosphere finely tuned to maintain habitability. Water covers about 70% of the surface, giving it a vibrant blue appearance from space, hence the blue planet. Earth's atmosphere protects life from harmful solar radiation and regulates temperature. Gravity keeps the oceans, air, and all living things anchored. Tectonic activity reshapes continents, while volcanoes and earthquakes remind us the planet is alive and constantly changing. Life on Earth isn't just about survival, it's about interaction. Plants, animals, oceans, and the air form a complex web of connections, all dependent on sunlight, water, and the planet's climate systems. And even humans, tiny as we are part of this web, influencing the planet in ways both subtle and dramatic. When you look at Earth from space, it's hard not to feel awe. It's a planet of extremes and balance, beauty and danger, activity and calm, a perfect cradle for life in an otherwise vast and inhospitable universe. Fact 25. Mars. The red frontier, Mars is the red planet glowing faintly in the night sky, teasing us with its dusty landscapes and towering mountains. It's smaller than Earth, with a thin atmosphere, yet it has captured human imagination for centuries as a potential future home. Its surface is covered in iron-rich dust, giving it that signature reddish colour. Mars has the tallest volcano in the solar system, Olympus Mons, and the deepest canyon, Valles Marineris, dwarfing anything on Earth. Water exists mostly as ice, but ancient riverbeds suggest Mars once had liquid water flowing across its surface. The planet experiences seasons like Earth because of its tilt, though winters are longer and colder. Dust storms can engulf the entire planet, sometimes lasting months, making exploration challenging. Yet, Mars missions, rovers, orbiters, and even satellites keep revealing secrets, evidence of past lakes, minerals shaped by water, and patterns hinting at climate shifts. Mars represents both a mystery and a possibility. It's a world that reminds us how fragile life is, how unique Earth truly is, and how exploration can push humanity to reach beyond its home planet. The red planet is a frontier, waiting for discovery, and it might one day become part of our story in space. Fact 26. Jupiter, the giant gas planet. Jupiter is the ultimate heavyweight of our solar system. Imagine a planet so massive that it could fit all the other planets inside it. That's Jupiter. It's a gas giant, mostly hydrogen and helium, with no solid surface as we know it. Instead, swirling clouds, raging storms, and colourful bands dominate its atmosphere. The most famous feature, the Great Red Spot, a storm larger than Earth that's been raging for centuries. Winds in Jupiter's atmosphere reach hundreds of miles per hour, creating a chaotic, ever-changing dance of clouds. And beneath those clouds, scientists believe there might be a dense core, surrounded by layers of metallic hydrogen, a state of matter that doesn't exist naturally on Earth. Jupiter also has an impressive family of moons, over 90 confirmed, including Europa, which might harbour a subsurface ocean, and Ganymede, the largest moon in the solar system. These moons are worlds in their own right, orbiting the giant like a mini solar system. Jupiter's gravity is so strong that it helps shield Earth from incoming asteroids and comets, acting as a cosmic bodyguard. It's not just a massive ball of gas, it's a protector, a laboratory of extreme weather, and a window into the dynamics of giant planets both here and in distant solar systems. Fact 27. Saturn. The ringed wonder. Saturn is impossible to miss in the night sky, thanks to its iconic rings. These aren't solid. They're made of billions of icy and rocky particles, ranging from tiny grains to massive chunks, all orbiting Saturn like a cosmic carousel. The rings give Saturn its signature beauty, but they also hint at its mysterious history, perhaps remnants of a shattered moon or leftover debris from its formation. Like Jupiter, Saturn is a gas giant, mostly hydrogen and helium. Its atmosphere is filled with bands of clouds, storms, and even long-lasting hexagonal patterns near the poles. Saturn also spins incredibly fast, completing a rotation in just over 10 hours, giving it a noticeable bulge at the equator. Saturn is home to dozens of moons, each unique. Titan, its largest, has lakes of liquid methane and a thick atmosphere, making it one of the most intriguing worlds in the solar system. And Enceladus hides a subsurface ocean that spews water into space, a potential hint at conditions for life. Saturn isn't just about rings and beauty. It's a dynamic, living system that challenges our understanding of planetary science and reminds us that the solar system is full of wonders beyond our imagination. Fact 28. Uranus, the tilted planet. Uranus is the solar system's oddball. Unlike other planets, it spins on its side with an axial tilt of about 98 degrees. Imagine a rolling bowling ball orbiting the Sun. Summer and winter on Uranus last for decades because of that extreme tilt. It's an ice giant, made mostly of water, ammonia, and methane ices. Methane gives Uranus its signature blue-green colour, absorbing red light and reflecting blue. Its atmosphere is relatively calm compared to Jupiter and Saturn, but it has powerful winds and occasional storms that make it a dynamic planet. Uranus has a faint ring system and over 27 known moons, many of them named after characters from literature. Its tilted rotation means that its poles get extreme sunlight for decades at a time, creating unusual weather patterns and seasonal changes unlike anywhere else in the solar system. Uranus reminds us that not everything in space behaves according to our expectations. Its sideways spin and icy composition make it a unique laboratory for understanding planetary formation and the forces that shape distant worlds. Fact 29. Neptune. The winds of ice. Neptune is the farthest planet in our solar system, a deep blue world of ice and gas. It's similar in size and composition to Uranus, but it's famous for its intense winds, the fastest in the solar system, reaching over 2,300 miles per hour. Like Uranus, Neptune's blue hue comes from methane, but its atmosphere also has visible storms, dark spots, and massive clouds racing across its surface. Despite being billions of miles from the Sun, Neptune generates internal heat that fuels these storms, making it surprisingly active for a world so far away. Neptune has 14 known moons, the largest being Triton, which orbits backward, a hint that it might have been captured from the Kuiper Belt. Triton has geysers, ice volcanoes, and a thin atmosphere, showing that even distant moons can be dynamic and fascinating. Neptune represents the extremes of the solar system, icy, windy, and distant, yet full of activity. It's a reminder that even in the far reaches, planets have personalities, storms, and secrets waiting to be explored. Fact 30. Dwarf planets, Pluto and friends. The solar system has smaller members that don't fit the classic planet definition, dwarf planets. Pluto, once the 9th planet, is the most famous, but there are others like Eris, Haumea, and Makemake, scattered mostly in the Kuiper Belt beyond Neptune. Dwarf planets are tiny worlds, often icy, with unique features. Pluto has mountains of water ice, plains, and even a thin atmosphere that expands and contracts as it moves closer or farther from the Sun. These small worlds are remnants from the solar system's formation, giving scientists clues about how planets and moons came to be. Despite their size, dwarf planets are fascinating. They orbit the Sun, interact with other objects, and sometimes have moons of their own. They may not dominate the solar system like Jupiter or Saturn, but they hold secrets of the early solar system and remind us that size doesn't determine importance. Dwarf planets are the quirky, distant cousins of the planets, a reminder that the solar system is diverse, full of surprises, and that even the smallest worlds have stories worth telling. Fact 31. The Moon, Earth's constant companion. Look up at the night sky and you'll see it. Our moon, quietly orbiting Earth for billions of years. It's more than a bright rock in the sky. It's a stabilizer, a storyteller, and a silent witness to Earth's history. The moon is about 1/4 the size of Earth, but its influence is enormous. Its gravity affects our oceans, its presence stabilizes Earth's tilt, and its phases have guided human calendars for millennia. Unlike the sun, which provides light and warmth, the moon reflects sunlight, creating the soft glow that has inspired myths, poetry, and science alike. The surface is rocky, marked by craters, mountains, and vast plains called Maria, ancient lava flows frozen in time. From Earth, it seems serene and unchanging, but it has been shaped by countless impacts, volcanic activity, and even the slow pull of gravity over billions of years. Humans have walked on it, studied it, and even brought back pieces, but the moon still holds mysteries. Its origin is believed to be a giant collision between Earth and a Mars-sized object billions of years ago, which created the moon from debris. Every night it rises and sets, a constant companion, reminding us of the cosmic dance between Earth and space. Fact 32. Lunar phases. Why the moon changes shape. Have you ever noticed that the moon isn't always the same? Some nights it's full, glowing like a lantern. Other nights it's just a sliver, barely visible. These lunar phases happen because of the moon's position relative to Earth and the sun. As the moon orbits Earth, the sunlight hits it from different angles. When the side facing Earth is fully illuminated, we see a full moon. When only a sliver is lit, we see a crescent. The phases follow a roughly 29.5-day cycle, moving from new moon to crescent, first quarter, gibbous, and full, then back again. Lunar phases are more than a pretty display. They've influenced calendars, planting cycles, tides, and human culture for thousands of years. Ancient civilizations used the moon to track time, and even today it subtly affects life on Earth. Watching the moon change shape can be mesmerizing. It's a reminder that even familiar objects in the sky are part of a dynamic system, moving, evolving, and influencing Earth in ways we often take for granted. Fact 33. Tides. How the moon moves our oceans. The moon doesn't just light up the night, it moves our oceans. Its gravity pulls on Earth's water, creating tides, the rise and fall of sea levels that shape coastlines, ecosystems, and even human activity. When the moon is overhead, water bulges toward it, creating high tide. On the opposite side of Earth, another high tide forms due to centrifugal forces. Tides aren't just a daily rhythm, they influence marine life, navigation, and climate patterns. Coastal plants and animals have evolved to rely on the tide's predictability, and humans have historically timed fishing, travel, and settlement around these patterns. Interestingly, the sun also plays a role. When the sun and moon align, we get especially high or low tides called spring tides. When they are at right angles, the tides are smaller, called neap tides. The moon, in its quiet orbit, orchestrates a delicate, ongoing rhythm that connects Earth and ocean in ways we can see and feel every day. Fact 34. Mars moons, Phobos and Deimos. Mars has 2 tiny moons, Phobos and Deimos, named after the Greek words for fear and panic. They're nothing like our moon, small, irregularly shaped and heavily cratered. Phobos is closer, orbiting Mars so fast that it rises in the west and sets in the east, completing a loop in just 7 hours. Deimos, smaller and farther away, takes longer and moves more slowly across the sky. Both moons are thought to be captured asteroids from the outer solar system. Their surfaces are covered in dust and craters, and scientists wonder if Phobos might one day break apart, forming a ring around Mars. Despite their size, these moons play a role in Mars' gravitational environment and could even become waypoints for future exploration. Phobos and Deimos remind us that moons don't have to be big or beautiful to be important. They're clues to Mars's history, its environment, and the cosmic processes that shape worlds beyond Earth. Fact 35. Jupiter's moons. Europa and Ganymede. Jupiter isn't just a giant planet, it's a miniature solar system with over 90 moons, each unique. Two of the most fascinating are Europa and Ganymede. Europa is covered in ice, and scientists believe a vast ocean flows beneath its frozen surface, possibly more water than all of Earth's oceans combined. This hidden ocean makes Europa one of the most exciting places in the solar system to study for potential life. Ganymede is even larger than Mercury, the solar system's smallest planet. It has its own magnetic field, an icy crust, and possibly subsurface oceans as well. Imagine a moon so big it dwarfs planets, quietly orbiting a giant planet thousands of times farther from the Sun than Earth. These moons show that Jupiter's influence extends far beyond its visible atmosphere. Its gravity shapes their orbits, creates tidal heating, and even stretches surfaces, producing cracks, ridges, and mysterious patterns. Europa and Ganymede aren't just moons, they're worlds of possibility, reminding us that exploration in our solar system is full of surprises. Fact 36. Saturn's moons. Titan and Enceladus. Saturn has over 80 known moons, but two stand out: Titan and Enceladus. Titan is a giant larger than Mercury, with a thick nitrogen-rich atmosphere and lakes of liquid methane and ethane. Its surface is dotted with rivers, dunes, and icy mountains, creating landscapes eerily similar to Earth's, despite being extremely cold. Titan even experiences seasonal changes, making it one of the most Earth-like places in the solar system in terms of weather and surface activity. Enceladus, though smaller, is equally fascinating. Its icy surface hides a global ocean beneath, and geysers of water vapour shoot into space from cracks near its south pole. These plumes contain organic molecules, making Enceladus a prime candidate in the search for conditions that could support life. Together, Titan and Enceladus showcase the diversity of Saturn's moons, from massive atmospheric worlds to small geologically active ones. Saturn isn't just a planet with rings, it's a hub of moons with stories, mysteries, and potential for discovery. Fact 37. Asteroids. Leftovers. From solar system formation. Asteroids are the leftover building blocks of the solar system. Most orbit between Mars and Jupiter in the asteroid belt, remnants of material that never formed a planet. They vary in size, from tiny rocks to objects hundreds of miles across, and in composition, ranging from metallic to rocky to carbon-rich. These space rocks are more than debris. They provide a window into the early solar system, holding clues about the formation of planets, and even the origins of water and organic molecules on Earth. Some asteroids pass close to Earth, reminding us that space is dynamic and full of moving objects. Exploring asteroids isn't just about science. Missions like OSIRIS-REx and Hayabusa 2 bring back samples, helping us understand chemistry, history, and even future asteroid mining possibilities. Asteroids may be small, but they carry massive stories about our cosmic neighbourhood. Fact 38. Meteors and meteorites, shooting stars. That hit Earth, ever wished on a shooting star? Those streaks of light aren't stars at all. They're meteors, bits of space rock burning up in Earth's atmosphere. Most are tiny, disappearing before hitting the ground, but larger ones can survive as meteorites. Meteorites are like cosmic postcards from the early solar system. By studying them, scientists learn about the materials that formed planets, moons, and even life on Earth. Some meteorites contain minerals older than the Earth itself, giving us a direct link to the time before our planet existed. Meteor showers are reminders that Earth moves through regions of space filled with debris, often left behind by comets. These natural fireworks show the ongoing interaction between Earth and the wider solar system, a cosmic connection we can literally see in the night sky. Fact 39. Comets. Cosmic snowballs. Comets are icy travellers from the outer solar system. Made of rock, dust, and frozen gases, they orbit the Sun in elongated paths. As they approach, sunlight heats the ice, creating spectacular tails of gas and dust that can stretch millions of miles. Comets are time capsules. They preserve material from the birth of the solar system, allowing scientists to study the ingredients present when planets were forming. Some comets may have even delivered water and organic molecules to early Earth, playing a role in the emergence of life. Watching a comet streak across the sky is more than beautiful. It's seeing ancient history in motion. These icy wanderers remind us that the solar system is alive, full of objects on long journeys shaped by gravity, heat, and time. Fact 40. Planetary rings, more than just Saturn. When you think of rings, Saturn comes to mind immediately, and for good reason. They're spectacular. But Jupiter, Uranus, and Neptune also have rings, though fainter and less prominent. Rings are made of ice, rock, and dust, orbiting a planet in delicate balance. Saturn's rings are massive and complex, with gaps, waves, and even moons embedded within them. They're not permanent. Over millions of years, ring material drifts, collides, or falls into the planet. Studying rings helps us understand planetary formation, moon interactions, and the dynamics of orbital systems. Rings are more than decoration. They're laboratories for studying gravity, collisions, and the forces that shape planetary systems. Every loop of ice and rock tells a story about the planet it surrounds and the cosmic history that created it. Fact 41. Solar flares. The Sun's explosive mood. Sometimes the Sun doesn't behave quietly. It erupts. Solar flares are sudden bursts of energy and light from the Sun's surface, caused by tangled magnetic fields snapping into place. These flares release vast amounts of radiation into space, equivalent to billions of nuclear bombs going off at once. The effects of solar flares can reach Earth, disrupting satellites, communications, and even power grids. While our atmosphere protects us from harmful radiation, technology is much more vulnerable. For astronauts in space, solar flares are a serious hazard, so monitoring the Sun's activity is crucial. Despite their danger, solar flares are fascinating. They reveal the Sun's dynamic nature, the power of magnetic forces, and the energy that drives our entire solar system. They remind us that the Sun is alive, unpredictable, and capable of influencing our planet in ways both beautiful and powerful. Fact 42. Coronal mass ejections, space weather dangers. If solar flares are fireworks, coronal mass ejections, CMEs, are cosmic hurricanes. These massive bursts of charged particles and magnetic fields shoot out from the Sun's corona at millions of miles per hour, sometimes directed toward Earth. When CMEs hit our planet, they interact with Earth's magnetic field, creating geomagnetic storms. These storms can disrupt satellites, navigation systems, and even electrical grids. However, they also create one of the most beautiful natural phenomena, auroras, the dancing lights near the poles. CMEs are reminders that space weather isn't just distant, it can have real consequences for life and technology on Earth. Studying them helps us predict and prepare for solar events, and also teaches us about magnetic forces, plasma physics, and the Sun's enormous influence. Fact 43. Auroras, Earth's dancing lights. Auroras are one of nature's most magical displays. When charged particles from the Sun interact with Earth's magnetic field and atmosphere, they create glowing curtains of green, pink, and purple light in the polar skies. The aurora borealis dazzles in the north, while the aurora australis lights up the south. These lights aren't just beautiful, they're evidence of Earth's magnetic shield at work. Without our magnetosphere, solar particles would strike the surface directly, making the planet far less hospitable. The aurora's colours depend on which gases the particles collide with. Oxygen glows green or red, nitrogen appears blue or purple. Auroras remind us that Earth is part of a larger cosmic system. The Sun, the magnetic field, and the atmosphere all interact to create a show that's both scientific and awe-inspiring. Every flicker in the night sky is a connection between our planet and the Sun's energetic reach. Fact 44. Cosmic rays. High-speed visitors. Cosmic rays are energetic particles travelling through space at nearly the speed of light. Some originate from the Sun, others from distant supernovae, black holes, or even galaxies far away. When these particles reach Earth, most are blocked by the atmosphere, but a few penetrate and reach the surface. Cosmic rays are important for science. They help us study high-energy processes in the universe and understand radiation in space. For astronauts and spacecraft, cosmic rays are a significant concern, as they can damage electronics and even human tissue. Despite being invisible and intangible, cosmic rays are everywhere. They're reminders that space isn't empty. It's full of high-speed visitors moving across the universe, carrying information about the forces that shape stars, galaxies, and our solar system. Fact 45. Magnetospheres. Planetary shields. Earth isn't defenseless against the Sun. Our magnetosphere, generated by the motion of molten iron in the planet's core, acts as a protective bubble, deflecting charged particles from solar wind and cosmic rays. Without it, the atmosphere could erode over time, and life as we know it would struggle to survive. Magnetospheres aren't unique to Earth. Other planets, like Jupiter and Saturn, have strong magnetic fields that protect moons and shape space weather around them. Observing these shields helps scientists understand planetary interiors, solar interactions, and the conditions that make life possible. Magnetospheres also create spectacular effects. When charged particles are guided along magnetic field lines toward the poles, we get auroras, a visible sign of this invisible protection at work. Planetary shields remind us that even unseen forces are crucial, keeping worlds safe while creating beauty in the skies above. Fact 46. Gravity waves, ripples in space-time. Imagine tossing a stone into a pond. Waves ripple out from the point of impact, spreading across the water. Now, replace the pond with the fabric of space and time itself, and you have gravity waves, ripples caused by massive cosmic events. When black holes collide or neutron stars merge, they send these subtle disturbances travelling across the universe at the speed of light. Gravity waves were first predicted by Einstein's theory of general relativity over a century ago, but only recently detected directly. These waves carry information about events billions of light-years away, letting scientists hear cosmic collisions that would otherwise remain invisible. Detecting them isn't easy. Observatories like LIGO use lasers and ultra-sensitive instruments to measure the tiniest distortions, smaller than a fraction of a proton. Each detection is like receiving a message from the universe, telling a story of extreme gravity, collisions, and energy beyond comprehension. Gravity waves are invisible, intangible, yet they reveal the dynamics of the cosmos in ways light alone cannot. They remind us that space-time is alive, constantly shifting under the influence of massive objects, and that the universe speaks in whispers as well as light. Fact 47. Gamma-ray bursts, universe's explosive signals. Gamma-ray bursts, GRBs, are the universe's most energetic fireworks. They appear as sudden, intense flashes of gamma radiation, often lasting just milliseconds to minutes, but releasing as much energy as the Sun will in its entire lifetime. These bursts are thought to occur when massive stars collapse into black holes or when neutron stars collide. The resulting jets of energy shoot across space, travelling billions of light-years before reaching us. GRBs are unpredictable, but when observed, they provide insight into extreme physics, stellar death, and the life cycle of the cosmos. Though dangerous if one were close enough, gamma-ray bursts are far away, letting us safely study their power. They remind us that the universe is alive with violent, awe-inspiring events, energetic signals that travel across space to tell us the story of creation, destruction, and the endless cycles of stars. Fact 48. Supernovae, the death of massive stars. Supernovae are spectacular stellar deaths. When a massive star exhausts its fuel, its core collapses under gravity, triggering a titanic explosion that can outshine an entire galaxy. For weeks or months, the dying star releases enormous amounts of energy, scattering elements like carbon, oxygen, and iron into space. These explosions aren't just dramatic, they're essential. Supernovae seed the cosmos with the elements that form planets, atmospheres, and life itself. Without them, the universe would be a very different place. Stars would live and die quietly, leaving no material for the next generation of worlds. Observing supernovae teaches astronomers about stellar evolution, the properties of exploding stars, and even the expansion of the universe. They are cosmic endings that lead to new beginnings, a reminder that in space, destruction often sows the seeds of creation. Fact 49. Quasars, bright beacons. From afar, quasars are cosmic lighthouses, shining from the edges of the observable universe. Powered by supermassive black holes at the centres of distant galaxies, quasars emit enormous amounts of energy as matter falls into the black hole, forming an extremely hot accretion disk. Some quasars outshine their host galaxies by hundreds of times, making them visible across billions of light years. They're not just bright, they're ancient, showing us what the universe looked like when it was much younger. Studying quasars helps astronomers understand galaxy formation, black hole growth, and the evolution of cosmic structures. Quasars are beacons in both distance and time. Every photon reaching Earth carries a story from billions of years ago, connecting us to a universe far larger and older than our own solar system. Fact 50. Nebulae, clouds that become stars. Nebulae are cosmic nurseries, vast clouds of gas and dust where stars are born. Gravity pulls material together, forming dense regions that heat up until a nuclear fusion ignites, creating new stars. Some nebulae glow brilliantly, illuminated by nearby stars, while others remain dark, hiding the secrets of star formation within. Famous examples include the Orion Nebula and the Eagle Nebula, with its pillars of creation sculpted by stellar winds. Nebulae aren't just beautiful, they're essential for life. They recycle elements from dying stars, providing the raw materials for planets, moons, and even organic molecules. When you look at a nebula, you're seeing the universe at work, destruction giving way to creation, chaos forming order, and clouds of gas turning into radiant stars that will light up the cosmos for billions of years. Fact 51. Earth's magnetic field, our invisible shield. Earth is constantly bombarded by particles from the Sun, yet we're mostly protected thanks to our magnetic field. Generated by the movement of molten iron in Earth's core, this invisible shield extends far into space, deflecting harmful solar wind and cosmic rays. Without it, solar particles could strip away our atmosphere over millions of years, leaving the planet exposed and lifeless. The magnetic field also guides compasses, influences animal navigation, and even interacts with the Sun to create the stunning auroras near the poles. Earth's magnetism isn't static, it drifts, flips, and changes over time. Scientists track these variations to understand the planet's interior, predict space weather impacts, and even study geological history. Though unseen, the magnetic field is a quiet guardian, constantly keeping life safe and our planet habitable. Fact 52. Earth's atmosphere, layers that protect us. Look up, and the blue sky is more than just a pretty view. It's the atmosphere, a life-sustaining blanket of gases surrounding Earth. Divided into layers, the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Each has a unique role in keeping our planet comfortable and protected. The troposphere contains the air we breathe and weather systems. The stratosphere houses the ozone layer, which shields us from harmful ultraviolet rays. Higher layers, like the thermosphere, absorb solar radiation and even glow during auroras. Without these layers, Earth would be exposed to extreme temperatures, radiation, and deadly space debris. The atmosphere also maintains pressure, allowing water to exist in liquid form, and regulates temperature by trapping heat from the sun. Every gust of wind, every cloud, and every breath reminds us that this invisible layer is essential, dynamic, and constantly interacting with both Earth and space. Fact 53. The ozone layer, Earth's sunscreen. High above Earth, in the stratosphere, lies the ozone layer, a thin shield of ozone molecules absorbing harmful ultraviolet, UV, rays from the sun. Think of it as a natural sunscreen, protecting living organisms from radiation that could damage DNA, harm ecosystems, and increase the risk of disease. The ozone layer isn't uniform. It has thin spots, particularly over the poles. Human activity, like the release of certain chemicals, has created concerns about ozone depletion, but global efforts have helped the layer recover. The ozone demonstrates a delicate balance between Earth's chemistry, solar energy, and life's survival. Without it, Earth would be a much harsher place. Plants, animals, and humans all rely on this invisible layer to filter out the sun's most dangerous rays. It's a reminder that even small components of our atmosphere have enormous importance. Fact 54. Plate tectonics, Earth's ever-moving surface. Earth's crust isn't fixed. It's made of massive plates that float on the molten mantle below. This movement, called plate tectonics, shapes mountains, earthquakes, volcanoes, and ocean basins, constantly reshaping the planet's surface over millions of years. When plates collide, mountains rise. When they pull apart, oceans and valleys form, and when one slides under another, volcanic activity can erupt, creating islands and releasing gases into the atmosphere. Life and geography are deeply connected to these movements. Plate tectonics also plays a role in recycling Earth's crust, moving carbon and other materials through the mantle and atmosphere. It's a slow but powerful process that reminds us that our planet is alive, changing, and deeply interconnected, from deep inside the Earth to its surface and oceans. Fact 55. Seasons, caused by Earth's tilt. Why do we have seasons? It's all about Earth's tilt. The planet is tilted at about 23.5 degrees, so as it orbits the Sun, different regions receive varying amounts of sunlight throughout the year. When the northern hemisphere tilts toward the Sun, it experiences summer, with longer days and more direct sunlight. Meanwhile, the southern hemisphere experiences winter, with shorter, cooler days. Half a year later, the situation flips. Seasons influence agriculture, ecosystems, and even human behavior. They create cycles of growth, migration, and reproduction in plants and animals. The tilt doesn't just change weather, it sets the rhythm of life, reminding us that Earth's position and orientation in space shape the world in profound ways. Fact 56. Earth's orbit, our yearly journey. Around the Sun, every year, Earth takes an incredible journey around the Sun. Its orbit isn't a perfect circle, it's slightly elliptical, meaning the distance to the Sun changes as we move along. Yet this path is steady and predictable, keeping the climate relatively stable and allowing life to thrive. The orbit takes 365 days, creating our calendar year. As Earth moves, the Sun appears to shift in the sky, influencing the length of days and nights, and the angle at which sunlight hits different regions. This movement also interacts with Earth's tilt, giving us the rhythm of seasons. Earth's orbit is a delicate balance between gravity and motion. If we moved faster or slower, or if the path were different, the climate could be drastically altered. This yearly journey is more than a mechanical loop. It's the invisible highway that sustains life, plants, and the cycles of nature we depend on every day. Fact 57. Earth's rotation. Day and night. Explained. Have you ever wondered why the sun rises in the east and sets in the west? It's all thanks to Earth's rotation. The planet spins on its axis once every 24 hours, creating day and night. Rotation isn't just about light and darkness. It affects wind patterns, ocean currents, and even the behaviour of the atmosphere. The Coriolis effect caused by rotation shapes weather systems and ocean gyres, influencing climate around the globe. Earth's rotation is gradually slowing over time, thanks to the gravitational pull of the moon. In millions of years, days will be slightly longer, but for now, this steady spin creates a predictable rhythm for life, work, and activity. A daily reminder that Earth is a dynamic planet in constant motion. Fact 58. The Moon-Earth connection, tides and stability. Earth and the Moon are partners in a cosmic dance. The Moon's gravity pulls on our oceans, creating tides that rise and fall in predictable patterns. These tides influence marine ecosystems, shape coastlines, and even affect human activity like fishing and navigation. But the Moon does more than move water. It stabilizes Earth's tilt, preventing extreme wobbling that could create chaotic climate swings. Without the Moon, seasons could vary unpredictably, making life much more difficult to adapt to. The Moon and Earth are connected in subtle, yet profound ways. From controlling the oceans to maintaining stability in our climate, this companion has played a silent, essential role in shaping the conditions that make life possible. Fact 59. The Sun-Earth distance. Life depends on it. Earth orbits at an average distance of about 93 million miles from the Sun, a perfect Goldilocks zone. Too close, and the planet would be scorched. Too far, and it would freeze. This precise distance ensures water remains liquid, temperatures stay within habitable ranges, and life can thrive. The Sun's energy drives weather, fuels photosynthesis, and regulates climate. Seasonal changes, ocean currents, and even wind patterns all depend on the balance between sunlight and Earth's tilt. This distance isn't fixed forever. Gravitational interactions and long-term cosmic shifts can slowly alter Earth's orbit, but for now it provides the stability that sustains life. The Sun may seem far away, but its warmth, light, and gravitational pull create the perfect conditions for life on our fragile blue planet. Fact 60. Earth's axial tilt. Why we have seasons. Earth isn't upright. It's tilted at about 23.5 degrees. This axial tilt is the reason we experience seasons. As Earth orbits the Sun, different regions tilt toward or away from sunlight, changing the intensity and duration of daylight. When the northern hemisphere leans toward the Sun, it experiences summer while the southern hemisphere has winter, and vice versa 6 months later. This tilt affects temperature, ecosystems, and even human activity, influencing everything from agriculture to animal migration patterns. Without this tilt, there would be no distinct seasons. Life would have to adapt to more uniform conditions, and many natural cycles we depend on would change. Earth's axial tilt is a subtle, yet powerful force shaping the rhythm of our planet and the flow of life itself. Fact 61. Telescopes, windows to the cosmos. Imagine staring at the night sky with your eyes alone. Stars twinkle, but most of the universe remains hidden. That's where telescopes come in. These incredible tools gather light, magnify distant objects, and reveal cosmic details invisible to the naked eye. From the first refracting telescopes in the 17th century to today's powerful observatories, telescopes have expanded our understanding of the universe. They let us see planets around other stars, nebulae birthing new suns, and galaxies billions of light years away. Telescopes work in many wavelengths, not just visible light. Some detect infrared, ultraviolet, X-rays, or radio waves, each revealing unique aspects of the cosmos. Essentially, telescopes are our cosmic senses, letting us explore realms humans could never reach physically. Every new telescope opens a window to discovery, reminding us that the universe is far bigger and more fascinating than it appears from Earth. Fact 62. Hubble Space Telescope. Images that changed everything. Launched in 1990, the Hubble Space Telescope transformed astronomy. Orbiting above Earth's atmosphere, Hubble avoids the blurring effects of air, capturing crystal-clear images of distant galaxies, nebulae, and star clusters. Hubble has revealed the universe in breathtaking detail, from the colourful swirls of the Orion Nebula to galaxies forming just after the Big Bang. Its observations have helped measure the universe's expansion, detect exoplanets, and even discover mysterious cosmic phenomena like dark energy. Hubble isn't just a machine, it's a storyteller. Its images allow scientists and the public to see the universe in ways that were impossible just decades ago. Each photograph is a bridge between humanity and the cosmos, expanding our imagination while deepening our understanding of the vast universe we inhabit. Fact 63. James Webb Space Telescope. A new era of observation. The James Webb Space Telescope is the next frontier in astronomy. Unlike Hubble, Webb focuses on infrared light, allowing it to peer through dust clouds and glimpse the earliest galaxies formed after the Big Bang. Webb's massive gold-coated mirrors and advanced instruments let scientists study star formation, planetary atmospheres, and even the chemical composition of distant worlds. Its observations could reveal clues about the conditions necessary for life beyond Earth. Webb represents more than technology. It's a leap in curiosity, a tool that turns the invisible into visible. Each image or spectrum brings the universe closer, helping us understand our origins, our place, and the incredible variety of phenomena scattered across space and time. Fact 64. Radio astronomy. Listening to the universe. Not all cosmic signals are visible. Radio astronomy detects radio waves emitted by stars, galaxies, and other celestial objects. By listening instead of looking, astronomers uncover phenomena invisible in light, such as pulsars, cosmic microwave background radiation, and distant quasars. Radio telescopes can detect signals across vast distances, giving insight into the structure of galaxies, the behaviour of black holes, and even mysterious fast radio bursts. Arrays of telescopes, like the Very Large Array, combine signals to create detailed images, transforming invisible waves into tangible knowledge. Radio astronomy reminds us that the universe speaks in multiple languages. By tuning in, we can study cosmic processes otherwise hidden, revealing the universe's structure, energy, and secrets that light alone cannot convey. Fact 65. X-ray astronomy. Seeing the invisible. Some of the universe's most energetic events emit X-rays, invisible to our eyes. To detect them, astronomers use X-ray telescopes in space, since Earth's atmosphere absorbs these rays. These instruments reveal black holes, supernova remnants, and extremely hot gas in galaxy clusters. X-ray astronomy has uncovered phenomena like neutron stars with intense magnetic fields, stellar explosions, and shock waves in superheated gases. Each detection gives a glimpse into the violent, high-energy side of the cosmos, invisible without specialized instruments. X-ray telescopes allow us to see the invisible, extending our perception beyond what light shows. They reveal that the universe isn't just static and beautiful. It's active, energetic, and full of processes shaping everything we observe from our tiny corner of space. Fact 66. Observatories on Earth, peering beyond the sky. Even on our home planet, we can explore the cosmos. Observatories on Earth, built atop mountains or in remote deserts, offer astronomers clear, dark skies for studying stars, planets, and galaxies. By escaping city lights and atmospheric disturbances, these observatories capture sharper, more detailed images. Ground-based telescopes are not just passive watchers. With adaptive optics and advanced sensors, They can detect distant exoplanets, track asteroids, and study variable stars. Some specialize in infrared or radio waves, revealing details invisible to the human eye. Earth-based observatories remind us that we don't need to leave the planet to explore space. By carefully positioning our instruments and using technology creatively, we can peer billions of light-years into the universe, bridging the gap between our planet and the far reaches of the cosmos. Fact 67. Satellites. Eyes in orbit. Orbiting above the atmosphere, satellites serve as humanity's eyes in space. They monitor Earth, study the Sun, and observe distant galaxies. Unlike ground-based telescopes, satellites avoid atmospheric interference, producing crisp images across multiple wavelengths. Satellites like Hubble or weather monitoring satellites provide continuous data, helping scientists track storms, measure climate change, and explore distant celestial objects. GPS satellites even guide our daily lives, showing how space technology directly impacts Earth. Satellites are silent watchers, circling Earth while collecting information that fuels science, safety, and understanding of our planet and the universe. Each orbit provides a new perspective, reminding us that seeing from above opens a whole new dimension of discovery. Fact 68. Planetary probes, robots that explore other worlds. Some places in the solar system are too distant or too dangerous for humans. That's where planetary probes come in. These robotic explorers visit planets, moons, asteroids, and comets, sending back images and data that revolutionize our understanding of the solar system. Probes like Voyager, Cassini, and New Horizons have revealed Saturn's rings, Pluto's icy landscapes, and Jupiter's stormy atmosphere. They measure magnetic fields, detect chemical compositions, and even study weather patterns on other worlds. Planetary probes expand our reach, letting us explore without leaving Earth. They are extensions of human curiosity, quietly orbiting or landing on alien surfaces while collecting information that inspires, educates, and reshapes our view of the solar system. Fact 69. Space photography. Capturing the cosmos. The universe is breathtaking, and space photography lets us capture it in all its glory. From Hubble's colourful nebular images to photos of Earth from orbit, space photography translates invisible or distant phenomena into pictures we can appreciate on Earth. These images do more than look beautiful, they tell stories. Supernova remnants, spiral galaxies, and planetary landscapes reveal physical processes, cosmic history, and the scale of the universe. Each photo combines science and art, giving people everywhere a glimpse of the extraordinary cosmos beyond our atmosphere. Space photography reminds us that the universe is not just abstract science, it's a visual experience. Every captured image connects curiosity, technology, and human imagination, transforming raw data into awe-inspiring knowledge. Fact 70. Space stations. Living in orbit. Humans have not just visited space, we've learned to live there. Space stations like the International Space Station ISS orbit Earth, hosting astronauts for months at a time. These laboratories let scientists study microgravity, test life support systems, and conduct experiments impossible on Earth. Life in orbit is unique. Water, food, and air must be carefully managed. Astronauts float while eating, exercise to maintain muscles and bones, and conduct research on everything from plant growth to materials science. Space stations are hubs of international collaboration, bringing together expertise, technology, and human resilience. By living in orbit, we learn not just about space, but about ourselves. How life adapts to new conditions, how science advances under unusual circumstances, and how humanity can extend its presence beyond Earth. Fact 71. Apollo missions, humans on the Moon. The Apollo missions were humanity's first steps beyond Earth, culminating in astronauts walking on the Moon. Apollo 11 in 1969 made history when Neil Armstrong and Buzz Aldrin set foot on lunar soil. leaving footprints that remain unchanged to this day. These missions weren't just about reaching the moon. They tested technology, navigational skills, and human endurance in space. Scientists collected rock samples, set up experiments, and studied the moon's environment, providing insights that continue to inform lunar science today. Apollo missions also inspired generations. They proved that with determination and innovation, humans could leave Earth and explore other worlds. Each mission added pieces to the puzzle of understanding the moon, space travel, and our potential in the cosmos. Fact 72. Mars rovers, robots, searching for life. Mars has fascinated humans for centuries, but the planet's distance makes exploration tricky. That's where Mars rovers come in. Robotic explorers traversing its surface to study rocks, soil, and atmosphere. Rovers like Spirit, Opportunity, Curiosity, and Perseverance search for evidence of water, past environments, and conditions that could support life. They take photos, analyze chemical compositions, and even drill into rocks to uncover Mars history. These robotic explorers are not just machines, they're our remote senses on another world. Each discovery brings us closer to understanding whether Mars could have hosted life, shaping plans for future human exploration. Fact 73. Voyager probes. Leaving the solar system launched in 1977, the Voyager probes were designed to explore the outer planets. But their journey didn't stop there. They continue travelling into interstellar space, carrying information about our solar system into the galaxy. Voyager 1 and 2 have passed Jupiter, Saturn, Uranus, and Neptune, sending back stunning images and data about planets, moons, and rings. Beyond that, they carry the Golden Record, a message from Earth, with sounds, music, and images representing life on our planet. Voyager probes remind us that exploration isn't just for our lifetimes. They're ambassadors of human curiosity, drifting into the unknown, telling the universe that we exist, study, and wonder. Fact 74. New Horizons are close. Look at Pluto. The New Horizons mission gave humanity its first detailed view of Pluto. Before this probe, Pluto was a tiny, blurry dot in telescopes, a mysterious edge of our solar system. In July 2015, New Horizons flew past Pluto, capturing high-resolution images of its icy mountains, plains, and heart-shaped glaciers. The mission also revealed its thin atmosphere, moons, and unexpected geological activity, transforming our understanding of this dwarf planet. New Horizons shows how exploration can rewrite assumptions. It reminds us that even distant, tiny worlds have stories, landscapes, and processes just as fascinating as planets closer to the Sun. Fact 75. SpaceX and commercial. Spaceflight. The new space race. Space travel is no longer just government-led. Companies like SpaceX have revolutionized access to space, developing reusable rockets, cargo missions, and crewed flights to the International Space Station. Commercial spaceflight lowers costs, encourages innovation, and brings the dream of space exploration closer to more people. It's a new era where private companies collaborate with governments, pushing boundaries and inspiring a fresh generation of explorers. SpaceX and similar ventures demonstrate that space is becoming a shared frontier. They highlight human ingenuity, the drive to innovate, and the belief that exploration isn't limited. It's expanding into a future where access to the stars may be more common than ever. Fact 76. International Space Station. Global collaboration in orbit. Orbiting roughly 250 miles above Earth, the International Space Station, ISS, is a marvel of engineering and cooperation. Built by multiple countries, including the United States, Russia, Japan, Canada, and European nations, it serves as a living laboratory in space. Astronauts live aboard the ISS for months at a time, conducting experiments in microgravity that can't be replicated on Earth. From studying human health and plant growth, to testing materials and technology for future space missions, the ISS is a hub of scientific discovery. Beyond research, the ISS is a symbol of global teamwork. Engineers, scientists, and astronauts from different cultures work together, overcoming challenges like logistics, language barriers, and technical complexities. The ISS shows that space is a frontier where collaboration can thrive, and that humanity can achieve extraordinary feats when united by curiosity and purpose. Fact 77. Moon landings. Facts versus myths. The moon has fascinated humans for centuries, and the Apollo missions brought the dream closer than ever. But with fame came myths and misconceptions. Some people question the landings, but evidence is overwhelming. Thousands of engineers, technicians, and astronauts made history, leaving equipment, experiments, and footprints still visible today. Lunar rocks brought back from the moon are unique and have been studied worldwide, confirming their extraterrestrial origin. Photos, videos, and telemetry data all document the missions in meticulous detail. Understanding the facts versus myths reminds us why critical thinking and scientific evidence matter. The moon landings weren't just stunts. They were triumphs of engineering, courage, and international attention to exploration, proving humans can extend their reach beyond Earth. Fact 78. Asteroid missions, mining and exploration. Asteroids are more than leftover space rocks. They're treasure chests of material. Missions like OSIRIS-REx and Hayabusa 2 have collected samples from these celestial bodies, helping scientists understand the early solar system. Asteroids contain metals, water, and organic molecules, which could be valuable for future space exploration or even resource mining. Understanding their composition also helps protect Earth from potential collisions, as monitoring and predicting asteroid paths can prevent disasters. Exploring asteroids combines science, technology, and planning for the future. They're both windows to the past and keys to humanity's expansion into space, showing that even small rocks can hold big possibilities. Fact 79. Future Mars. Missions. Humans to the Red Planet. Humans have sent robots to Mars for decades, but the next frontier is sending people. Future missions aim to land astronauts, explore the surface, and test the technologies needed for long-term habitation. Challenges are immense. Radiation, low gravity, limited supplies, and communication delays all pose risks. Yet progress is underway, with international space agencies and private companies developing spacecraft, habitats, and life support systems. These missions are more than technical achievements. They represent humanity's desire to explore, adapt, and reach beyond our home planet. Mars isn't just a destination. It's a testing ground for the future of human space exploration, inspiring generations to imagine life on another world. Fact 80. Deep space missions. Reaching beyond, some missions venture far past the planets we know, exploring the outer solar system and beyond. Deep space missions like Voyager, New Horizons, and upcoming interstellar probes travel billions of miles to study distant planets, comets, and cosmic phenomena. These missions push technology, testing communication across immense distances and functioning in harsh, unknown environments. They bring back data about the edges of our solar system, the influence of the sun, and the structure of space itself. Deep space missions remind us that exploration isn't limited to nearby planets. They extend humanity's curiosity to the furthest reaches, where every discovery is a reminder of how vast, dynamic, and fascinating the universe truly is. Fact 81. Water in space. The key to life. Water is essential for life as we know it, and finding it beyond Earth is a major focus for scientists. From ice on the moon to liquid beneath Europa's icy crust, water exists throughout the solar system in surprising ways. Water isn't just a resource, it's a clue. Its presence indicates conditions that could support life, past or present. On Mars, Signs of ancient rivers and seasonal flows suggest the planet may once have had habitable environments. Even asteroids and comets carry water, hinting that they may have helped deliver it to Earth. Studying water in space connects us to the broader question: how common is life in the universe? It's a reminder that even small molecules can hold enormous importance, shaping the potential for life on other worlds and helping guide our exploration of the cosmos. Fact 82. Extramophils. Life that survives anywhere. Some life on Earth thrives in conditions that would seem impossible: intense heat, freezing cold, crushing pressure, or toxic chemicals. These hardy organisms, called extremophiles, show that life can adapt to almost anything. From bacteria living deep in ocean vents to microbes surviving frozen glaciers, extremophiles expand our understanding of habitability. If life can exist in Earth's harshest places, it may also survive on planets or moons previously considered inhospitable. Studying extremophils not only teaches biology, it informs astrobiology, helping scientists identify where to look for life in the solar system and beyond. These resilient creatures are reminders that life is often more adaptable than we imagine, thriving in conditions once thought impossible. Fact 83. Habitability. What makes a planet friendly? What makes a planet capable of supporting life? Habitability depends on several factors: water, atmosphere, temperature, chemical composition, and even magnetic protection. A planet needs the right balance to sustain life over long periods. Scientists also consider the location within a star system, the habitable zone, where temperatures allow liquid water to exist. Planets too close to their star might boil away water, while those too far could freeze entirely. Stable orbits, protective atmospheres, and chemical ingredients for life are also essential. Habitability isn't just about survival. It's about creating conditions where life can thrive and evolve. By understanding these factors, we can focus our search on planets most likely to host living organisms, turning science fiction into plausible exploration. Fact 84. Exoplanets. Other worlds, other possibilities. The discovery of exoplanets, planets orbiting stars beyond our Sun, has changed our understanding of the universe. Thousands have been found, ranging from Earth-like rocky planets to massive gas giants, each with unique characteristics. Exoplanets help us explore questions of habitability, atmospheric composition, and even potential for life. Some reside in habitable zones with conditions that might allow water to remain liquid, while others are extreme worlds with scorching temperatures or violent weather. Each discovery expands our perspective. Earth is just one of countless worlds. Exoplanets are windows into possibilities, challenging our assumptions and inspiring the search for life, resources, and knowledge beyond our solar system. Fact 85. Search for extraterrestrial life. Are we alone? Humans have long wondered, are we alone in the universe? From Mars rovers to space telescopes, the search for extraterrestrial life combines biology, astronomy, and planetary science. Scientists look for water, habitable environments, and biosignatures, clues that life might exist elsewhere. Programs like SETI, Search for Extraterrestrial Intelligence, listen for signals from distant civilizations, while missions study moons, planets, and exoplanets for signs of past or present life. Even extremophils on Earth guide our expectations, showing that life can thrive in unexpected conditions. The search for extraterrestrial life is a journey of curiosity and imagination. Every discovery, from water on moons to habitable exoplanets, brings us closer to answering one of humanity's oldest questions. Are we alone, or is life more common than we ever imagined? Fact 86. SETI. Listening for signals. Humans have always wondered if we're alone in the universe, and SETI, the Search for Extraterrestrial Intelligence, is our scientific attempt to answer that question. Using powerful radio telescopes, scientists scan the skies for patterns or signals that might indicate intelligent life elsewhere. CT doesn't assume that aliens will send messages in the ways we expect. It looks for anomalies in radio frequencies, light patterns, and other forms of communication that could suggest non-random activity. Every signal detected is carefully analysed, distinguishing natural cosmic phenomena from potential artificial sources. SETI is more than technology, it's a symbol of curiosity. Listening to the cosmos reminds us of the vastness of space and our desire to connect, to know whether life exists beyond Earth. Even if we haven't yet found another civilization, the search fuels imagination, innovation, and the ongoing question, are we truly alone? Fact 87. Astrobiology. Science of life in space. Astrobiology is the study of life in the universe. It combines biology, chemistry, and astronomy to understand where life could exist and how it might survive beyond Earth. Scientists study extreme environments on our planet to learn how life adapts, then apply those lessons to other worlds. Astrobiology isn't just about searching for aliens, it's about understanding life itself. From microbes living in acidic lakes to organisms thriving under extreme radiation, these studies provide clues about survival strategies, planetary conditions, and the potential for life on Mars, Europa, or exoplanets. By bridging Earth and space, astrobiology gives a scientific framework to one of humanity's biggest questions. How does life arise, adapt, and possibly exist elsewhere in the cosmos? It's a field that blends exploration, imagination, and rigorous observation. Fact 88. Earth's biosphere. A delicate balance. Earth's biosphere is the zone where life exists, encompassing land, water, and air. It's a complex, interconnected system where every organism, climate pattern, and ecosystem contributes to a delicate balance. Plants produce oxygen, oceans regulate temperature, and microbes recycle nutrients. Even small changes like shifts in temperature or pollution levels can ripple through ecosystems, affecting countless species. Human activity has become a major factor in this balance, demonstrating how sensitive life is to environmental shifts. Understanding Earth's biosphere is crucial for space exploration. If we hope to create sustainable habitats on other worlds, we must first grasp how life thrives here. The biosphere teaches lessons about interdependence, resilience, and the intricate systems that make a planet habitable. Fact 89. Space farming, growing food. Beyond Earth, long-term space missions need more than water and oxygen, they need food. Space farming explores how plants grow in microgravity in confined environments. Experiments on the ISS have tested crops like lettuce, radishes, and wheat, showing that life can adapt even when gravity is low. Space farming isn't just practical, it's essential for future missions to the Moon, Mars, or deep space. Growing food in orbit reduces reliance on resupply missions, recycles waste, and helps sustain human crews on long journeys. Controlled environments, hydroponics, and LED lighting are all part of the solution. Each plant grown in space is a step towards self-sufficiency, proving that life can adapt to new worlds. Space farming merges science, engineering, and biology, reminding us that exploration isn't just about machines, it's about sustaining life far from home. Fact 90. Effects of microgravity on humans. Body and space. Living in space isn't like living on Earth. Microgravity affects every part of the human body. Muscles weaken, bones lose density, fluid distribution changes, and even the cardiovascular system adapts to weightlessness. Astronauts exercise regularly to counteract these effects, but prolonged missions present unique challenges. Microgravity also affects balance, coordination, and the senses. The brain adjusts to floating and reorienting, while astronauts notice changes in vision and even taste. Studying these effects is critical for planning longer missions to Mars or beyond. Understanding how the human body reacts to microgravity is more than science, it's preparation. By exploring and adapting to these conditions, we learn how to survive, thrive, and maintain health in environments far from the comfort of Earth's gravity. Fact 91. The universe is expanding. Faster. Every day, imagine the universe as a loaf of raisin bread baking in the oven. As the dough rises, every raisin moves away from the others. That's a simple way to picture the expansion of the universe. Galaxies are moving apart, and surprisingly, this expansion is accelerating. The discovery of this accelerating expansion in the late 20th century changed cosmology forever. Dark energy, an unknown force, is thought to drive this acceleration, pushing galaxies away from each other faster over time. Observing distant supernovae and galaxies confirms this trend. This expansion doesn't mean galaxies are moving through space in the usual sense. They're being carried along as space itself stretches. It reshapes our understanding of the cosmos, showing that the universe is dynamic, vast, and constantly changing. Every observation reminds us that the universe is not a static backdrop. It's alive, expanding, and full of surprises. Fact 92. Time dilation. Einstein's mind-bending theory. Time isn't as fixed as it feels. According to Einstein's theory of relativity, time can slow down depending on speed or gravity. This is called time dilation, and it's been proven through experiments with fast-moving particles, satellites, and clocks. For astronauts travelling near the speed of light or near massive objects like black holes, time passes differently than on Earth. A journey that feels like a few years to them could be decades back home. While this sounds like science fiction, it's a real effect that must be accounted for in GPS satellites and space missions. Time dilation challenges our everyday perception of reality. It reminds us that space, time, and gravity are intertwined in ways that are subtle, strange, and fascinating. The universe operates under rules far more flexible than human intuition suggests. Fact 93. Cosmic background radiation. Echo of the Big Bang. The cosmic microwave background, CMB, is the afterglow of the Big Bang, a faint microwave signal filling the entire universe. Discovered in the 1960s, it provides a snapshot of the universe when it was just a few 100,000 years old. CMB observations revealed tiny temperature fluctuations, which eventually grew into galaxies and cosmic structures. Studying this radiation allows scientists to determine the age, composition, and expansion of the universe with incredible precision. The cosmic background radiation is like a whisper from the beginning of everything, a faint signal that connects us to the origin of space and time. It's a reminder that the universe has a history, and that even billions of years later, we can still detect the echoes of its earliest moments. Fact 94. Rogue planets, free-floating wanderers. Not all planets orbit stars. Some drift alone through the galaxy. These are rogue planets. Untethered by a parent star, they travel silently through space, cold and dark, yet fascinating to astronomers. Rogue planets may have been ejected from their original systems or formed independently. Despite the lack of sunlight, some may harbour subsurface oceans warmed by internal heat, potentially allowing for life in extreme conditions. These wandering worlds challenge our understanding of planetary formation and habitability. They remind us that the universe is full of surprises, with planets that don't fit neatly into the rules we think we know. Every rogue planet is a story of cosmic independence, drifting through the galaxy alone. Fact 95. Space debris. Pollution in orbit. Earth's orbit isn't just a highway for satellites, it's also a dumping ground for debris. Old satellites, spent rocket stages, and fragments from collisions create a dangerous clutter circling the planet. Space debris moves at thousands of miles per hour, posing a threat to active satellites, space stations, and future missions. Even small fragments can cause serious damage due to their high velocity. Tracking and managing debris is a growing concern for space agencies. This orbital pollution reminds us that space is a shared environment. Just as we care for Earth, we must manage our activities in orbit. Without careful planning, our exploration of space could be limited by the consequences of our own neglect. Fact 96. Earth from space. Blue marble. Perspective. Seeing Earth from space is unlike any other experience. From orbit, our planet looks like a blue marble suspended in darkness, with swirling clouds, vast oceans, and green continents. Astronauts often describe an overwhelming sense of unity and fragility, the so-called overview effect. From this perspective, borders disappear, and the interconnectedness of ecosystems, oceans, and weather systems becomes clear. It's a reminder that Earth is a single dynamic system where every action, from storms to human activity, affects the whole planet. Observing Earth from space also inspires stewardship. Protecting our atmosphere, oceans, and land isn't abstract. It's essential for preserving the tiny, beautiful world that floats in the vastness of the cosmos. The blue marble perspective is both humbling and inspiring, a vision that unites science, wonder, and responsibility. Fact 97. Space travel. Challenges. Radiation, isolation, and more. Travelling beyond Earth is thrilling, but it comes with serious challenges. Cosmic radiation, microgravity, isolation, and limited resources all test the limits of human resilience. Long-duration missions to Mars or deep space amplify these effects, requiring careful planning. Radiation from the Sun and distant cosmic sources can damage DNA, increasing health risks. Microgravity weakens muscles and bones, while isolation affects mental health. Supplies must be managed meticulously, and communication delays complicate problem-solving. Understanding these challenges is critical for future exploration. Space travel demands innovation in technology, medicine, and psychology. Each mission pushes the boundaries of human capability, teaching us not only about space but also about how life adapts under extreme conditions. Fact 98. Solar System Oddities. Unusual facts about planets. Our solar system is full of surprises. Venus rotates backward, Uranus spins on its side, and Neptune has supersonic winds. Jupiter's great red spot is a storm larger than Earth. While Saturn's rings are made of ice and rock particles orbiting in intricate patterns. Even smaller bodies hold secrets. Pluto has heart-shaped glaciers, and moons like Titan have rivers and lakes made of methane. These oddities reveal the diversity of planetary formation and evolution, showing that our cosmic neighbourhood is far from uniform or predictable. Solar system oddities remind us that exploring space is always an adventure. Every planet, moon, or asteroid has unique characteristics, challenging assumptions and fueling curiosity about how the universe operates on both familiar and extreme scales. Fact 99. Cosmic coincidences, rare events in space. The universe sometimes aligns in ways that seem almost magical. Cosmic coincidences include perfect solar eclipses, where the moon covers the sun exactly, or exoplanets that mimic Earth's conditions almost perfectly. Even the timing of cosmic events, like the alignment of certain galaxies, creates rare opportunities for observation. These coincidences don't imply intention. They are natural results of physics, gravity, and chance. But they make space exploration thrilling, offering unique moments for discovery and study. Scientists can measure, analyze, and learn from these events, deepening understanding while inspiring wonder. Cosmic coincidences highlight the beauty and unpredictability of the universe. They remind us that space is full of surprises, rare alignments, and moments that spark both scientific insight and awe. Fact 100. Humanity's future in space, dreams and reality. The story of humanity in space is only beginning. From telescopes and probes to astronauts living aboard the ISS, we've already made remarkable strides. The future holds possibilities: colonies on the moon, human missions to Mars, asteroid mining, and even interstellar exploration. These dreams face technological, financial, and biological challenges. Life support systems, radiation protection, and sustainable food sources are critical for long-term survival. Yet innovation, collaboration, and curiosity drive progress, turning science fiction into achievable plans. Humanity's future in space isn't just about exploration. It's about survival, learning, and expanding our presence in the cosmos. Every mission, experiment, and discovery builds toward a future where life is not confined to one planet, proving that curiosity and determination can carry us far beyond our homeworld.